Hello everyone, myself Professor Tushar Gujarati from SNT College of Engineering Yeola. Today we'll study the control systems, that is PID forms. Means there are some forms of PID control action that we'll study. They are in parallel and series modes that we are to study now. So first of all we'll study PID series or interacting form. So here in this case proportional, integral and derivative controllers are connected in series form. Okay, now here you check the blocks. So here in this case this is the block of proportional, then derivative and integral. Okay, so these all inputs are given to some summing points. So here this is one summing point used where the proportional is added to this derivative. Okay, and now in this summing point then now this PD control is added to this I control. Okay, so understanding this, so what happens here, we require summing points. Okay, this summing point is required for adding these two signals. Okay, and for adding this signal with I we need again one more summing point. So what is input to the system, entire system input is E, error E is input to the system, and after at the end you will get U is nothing but the control action that will be generated. So here what is written, derivative action interacts with integral action, derivative action interacts with integral action, modification in derivative time constant affects integral action. So here modification occurs in derivative time constant and it affects integral action. So commercially used controller, this use controller is used commercially. Okay, so there is modification in drawbacks of derivative and integral and we get finally the result controlled. Okay, so we'll get U as a controlled output. So now what is transfer function of this series form? The transfer function of PID in series is taken as P plus PD in bracket 1 plus I. So this is the control action that get generates in series. Okay, so if you multiply this you will get P plus PI, okay, plus PD and plus PID. Okay, so like this you will get control action. So what happens here, the P action is present, PI is also present, PD action is also present and PID control actions are also present. So like this all control actions are taken in this series form and we get controlled output. So you should remember this equation, P plus PD in bracket 1 plus I. So P is proportional controller, I is integral controller and D is derivative controller. So here total transfer function is P plus PD plus PI plus PID. So suppose Ti is greater than 4 times Td, that is integral time is greater than 4 times derivative time. At the time what happens, PID becomes 0. Okay, because integral action is more as compared to derivative. So that's why we get, if derivative is 0, okay, then we get PID as 0, where Ti is integral time constant, Td is derivative time constant, and at the end finally we get equation as transfer function P plus Pi plus PD. So this is the final equation we get for series form. Okay, now we have to understood PID in the parallel form or it is called as non-interacting form. It is also called as non-interacting form. So now in this system you check what is shown over here. Now here the different blocks are connected in parallel. Okay, this is also called as 3 type of controller mode. So now in this case in the blocks what is written, the transfer function of all the 3 equations is written. Okay, so here Kp is written. Kp is nothing but transfer function of proportional system. Here Ki upon S, it is transfer function of integral system, and Kd into S, it is transfer function of derivative system. Okay, so now there is question how you get these transfer functions. Okay, so actually the transfer function of derivative, this first of all. So actually you know that output, that is output u is equal to what is derivative equation, u is equal to kd into de by dt. Okay, so this is in time domain, this equation is time domain, so we have to convert this equation in s domain. Okay, if we want to get transfer function, then we have to convert in s domain. So if you find the derivative transfer function of derivative or Laplace transform of derivative, okay, so what we get multiplication. So there is kd into s into e of s. Okay, like this we'll get, and here we will get u of s. Okay, so here transfer function is nothing but ratio of output upon input. So here u of s upon e of s, u of s is output and e of s is input, so we get this transfer function kd into s. That's why it is kd into s. So you should understand the formulas of Laplace transform. Here we have taken Laplace transform. You check your mathematics formulas, what is Laplace transform of derivative. So Laplace transform of derivative is nothing but we have to multiply the derivative by s. Okay, and we have to write in e of s formula. Okay, so derivative of, so Laplace transform of derivative is nothing but s into e of s. This is the Laplace transform of derivative. If there is double derivative is present, then we have to multiply by s square. If triple derivative, then we have to multiply by s cube. So here only single derivative is present, that's why we have multiplied by s into e of s. That's why we got in this table kd into s. Now if there is integration of equation is there, e of e into d of e dt. Okay, so at that time we have to, in the Laplace transform we get 1 upon s into e of s. Okay, like this we get 1 of s into e of s, and here we'll get u of s is equal to 1 upon s into e of s. That's why ratio of output upon input, that is u upon e, we get ki in upon s. That's why our second answer is ki upon s. And for constant of proportionality, there is no derivative and integral, that's why we get directly kp as a block. Okay, so here all the three blocks are added in parallel. Okay, and summation of these blocks is taken over here. Summation of block is taken, and here input is error, and like this we control the plant. Okay, so this is ideal form. Okay, ideal form of parallel form. So derivative action does not interact with integral action. Now when we connect in parallel, what happens? Derivative action does not interact with integral action. So here transfer function is nothing but addition of all the three transfer function, that is kp plus ki upon s plus kd into s. Okay, so these are all proportional gain, integral gain and derivative gain. So control signal is nothing but, control signal is addition of all the three outputs, u of t, ui of t and ud of t. So it is up of t, it is kp into e, proportionally kp into e. What is ui of t? Ki into integration of e dt. So here we have to take integration of error. And what is ud? It is kd into de by dt. So here we take derivative of error. So like this control signal is generated. And here e is nothing but, what is e? E is error. It is error of difference between reference and measured signal. So difference between measured and reference signal is called as error. So thank you so much friends for watching this video. So in this video we covered the series and parallel form of PID control action and what are its equations. Okay, that we have studied. So you should remember the diagram and you should remember the transfer function of the system in series as well as parallel form. Okay, so thank you so much for watching this video.